actually, the best way to do these, this is how I do it. Identify all the pieces, knew that, amplitude, period. Oops, I forgot to put reflections in here. Oh, that's later on. Later on, reflections are there. Okay, so you're going to identify these key pieces, and you're going to graph the 5 key points. Remember, you started at the y-axis, you counted out 4 lines, put your period, figure out what to graph it by, and then from there make all these changes. So this is the order that I would do it in. I would apply any reflections, going to do any phase shifts, I'm going to show you that now. And then the very last thing is I would do the up or down shifts, the change in the midline, very, very last. It makes things much easier if when you move it off that x-axis, everything else is done to it beforehand. Okay, let's identify. Amplitude, easy. That's 1/2. Now I'm going to make note of it right now. Since A is negative, that means we are going to reflect, but we'll do that later. Okay, we've got a B of 2. So my period is going to be 2 pi divided by 2, or pi. Now remember that other element is we need to know what to count by. So I'm going to take the period and divide it by 4, and that's what's going to be our counting unit. And then the new piece, oh wait, no midline, no change to midline, so the midline is still y equals 0. And then the phase shift, that's the new guy. Let's see, 2x minus pi equals 0. 2x equals pi, so x equals pi halves. And that's our phase shift. Okay, like I said, one piece at a time. My very, very first thing I'm going to do is graph the 5 key points, and all I'm applying is the amplitude and the period first, right? I'm not worried about reflections, phase shifts, or midlines, or anything else. So right now, all I'm going to graph, and we'll go with green first, I'm going to graph this 1/2 cosine, 1/2, not doing the reflection yet, I'm ignoring that, and then I'm going to go cosine of 2x. That's my very, very basic piece. And from there, I can apply any reflections, phase shifts, midline changes, anything like that. So to graph that, we need our amplitude and our period in order to label our line. So I'm going to start with here. Here's the beginning point 0. I'm going to count out 1, 2, 3, 4. And then we're going to put our units in there. It looks like our last one's going to be pi because that's our period. And then we said we're going to count in pi fourths. So this is pi over 4, 2 pi over 4, which is pi halves, and then 3 pi over 4, and last is that 4 pi over 4. Okay, and then we've got our amplitude is 1/2. Yeah, amplitude is 1/2. So we're going to go negative 1/2, positive 1/2, and there's all our units. Okay, 5 key points. For cosine, it starts at a maximum, ends at a maximum. In the middle is your minimum, and the other 2 pieces are your asymptotes. Or sorry, your intercepts. I don't know where asymptotes came from. Okay, now I'm going to connect the dots on this so that you can see that we've got our regular old cosine picture. But I'm going to erase and go just back to the dots so that you can see the movement of the dots rather than all the lines getting mixed together. But you can draw as many curves in there as you want to. I just have to keep it simpler on this graph. So next thing I'm going to do is I'm going to apply the reflection. So now my next equation that I'm technically graphing is I'm going to include this reflection now. So we're moving to orange. So this point right here, the starting point for cosine up to the maximum is now going to be a minimum. This minimum in the middle is a maximum, and it still ends at a maximum. That'll flip to become a minimum. And then the intercepts never change. So here is my reflected graph. Okay, That's check right there, check right there. Okay, let's move on to midline shifts. Oh, sorry, phase shifts. So we have decided that our phase shift, so now we're dealing with this whole y equals -1/2 cosine, but not just 2x now, it's going to be the 2x minus 1/2. So basically we're applying the phase shift. So do you see how I'm doing it one step at a time? And I'm doing different colors every time because it helps me to see which one went where. Now I'm leaving that orange line in there to see so that you can see this phase shift and exactly how it works. So anyways, our phase shift we decided was 1/2. That means instead of starting over here at the x equals 0 mark, this first dot has to be over here at the 1/2 mark. So instead of starting at 0, it's supposed to start at pi halves. Well, to get there, I had to shift 1, 2 lines, which means every other one of these points have to shift 2 lines. So for example, this one is going to go to there. This one is going to go to there. Let's see, our intercept, this guy right here, is going to go over 2 spots. Quit! Gosh, that stupid thing. To there. And then this point that was right there goes over 2 as well. And this is my graph with that phase shift. So green was the original base function with just amplitude and period changes. And then I went in and applied the reflection. Next, I did a phase shift, which, again, you're just literally picking up the graph and moving it over so many spots, and you just apply it to every single one of your key points. And then if there had been a midline shift up or down, I would have applied that last, and I would have just moved these points again, either up or down, from the red one. At this point, we're no longer looking at the green one or the orange one. Right now, we're at this final one, and if I'd had one more step to do a midline, then none of these other graphs would have been important. So it never hurts on your work to write that this is the final graph. Okay, let's try another one. So this one has 2 sine of 6x plus pi, and then minus 1 at the end. So it's a sine graph, right? We've got an amplitude of 2, a period of 2 pi over 6. This is still b, which is going to be pi over 3. Okay, our new midline will be at y equals -1. And our phase shift is going to be where 6x plus pi equals 0. Okay, subtracting, you end up with 6x equals -pi, and then x equals -pi over 6. And that's our new phase shift, right? So that's our new starting point. Midline change, let's see, amplitude, period. We need to know what to count by, right? Let's see. Let's start from here. Hello. P over 4, it's our counting point, is pi over 3 divided by 4, right? Pi over 3 times 1 over 4. Looks like we're going to be counting by pi over 12. Okay, basic sine function. Going to start with a basic guy here. So my first graph in blue is going to be 2 sine of 6x. I'm only taking into account that period change and that amplitude change. So here's my starting point. I'm going to count out 1, 2, 3, 4. My period, which was pi thirds, is going to go there. And then we're going to count by pi twelfths. So 1 pi twelfths, 2 pi twelfths, but 2 pi twelfths is pi sixth. So pi 6. and then 3 pi 12ths equals pi over 4. And then you've got 1, 2, 3, 4 pi over 12, which is your pi thirds. Okay, our amplitude is 2, so I'm going to label my y-axis 0, 1, 2, down is -1, -2. Okay, basic function. I'm actually going to have to change from blue because I just labeled it in blue. All right, so y equals 2 sine of 6x. Sine starts at the intercept. It ends at an intercept and has an intercept in between. And there's a maximum at 2 and a minimum of -2. And this is my original sine function after any, period or amplitude changes. Okay, that's my original one. Now again, I'm going to go back, take that guy out so I can just deal with points. Okay, next I'm going to apply any reflections. No reflections, so we're not going to worry about that. So no reflections. I'm going to move next to my phase shift. So now I'm going to graph y equals 2 sine. Now it's 6x, but technically that was 6x plus pi. And that's the phase shift. So what this means is now my graph has to start at negative pi 6 instead of at 0. So I'm going to actually have to label that left side of the line so I can see where negative pi 6 is. Okay, let's see, it was pi 12ths was the first one, so over here the first one will be negative pi 12ths. Next one will be negative pi 6. And that's far enough. I don't need to go any further. I just need to know where to start my new graph. All right, we are working in green. So here's my original point. That one's got to move over here to negative pi 6. And I went 2 points. Sorry, 2 lines. So this point right here, he's going to go over here too. Let's see, that was this point. This point's going to go over to here. This point to here. And this point goes to here. So that's where I'm at now as far as my transformations go. My new graph. Get those dashed lines over there, out of there. So these purple ones don't matter anymore. You can take the purple ones off the graph if you wanted to. We're only focusing on the green at this point. So we're done with this guy. Guess I didn't need to erase it. Don't need him anymore, not even paying attention to the purple dots. Okay, let's go with blue. Oh, not blue. Duh, we just said not blue. Hey, let's do orange. Okay, so now we can finally put in that midline shift. So now we've got our graph of 2 sine 6x plus pi. This is where we're at as far as graphing the pieces. And now we're going to apply that -1 in there. That's a midline shift. So instead of your midline being right here at y equals 0, now your midline's down here at -1. Now moving it down 1 means every one of these points get to move down 1. Just the green points, not even paying attention to those purple points. Okay, and then we connect the dots, making it a smooth sine curve. And that would be your final answer right there. And that's it. Not too bad. Just lots of pieces, step by step, and it makes it easy.